All right, ladies and gentlemen, today we are going to take a look at fractional exponents. So what happens basically if an exponent is a fraction? Now you have all this information in front of you, but I want to make sure that we understand kind of what this is saying. So there are two different rules that we can look at in terms of understanding what it means if there is a fraction exponent. The first one is that x to the 1 over n power is equal to the same thing as the nth root of x. Here's what that means. It means that the fourth root of x is the same as x to the 1/4, and you can obviously look at that in either direction, that x to the 1/4 is equal to the fourth root of x. Those are literally exactly the same thing. There is no difference between them. This also works in the example that we have over here, where if we have 16 to the 3/4, the 4 is going to become the index on the roots. So if it were 16 to the 1/4, it would just be the fourth root of 16. But since it's to the 3/4, it's going to be fourth root of 16 to the third. Now that exponent can go either under the root, as you see here, or outside of the root. So again, as an example, if we had x to the 4/5, that would be the same thing as the fifth root of x to the fourth. Okay, and again, so we can see where all those are coming from. That denominator is the same as the index of a root, and the numerator is still just like a regular exponent. Now, you have all sorts of other information on this sheet that is probably really helpful. But without looking at those examples first, the first thing I really want to do is make sure we understand why this actually makes sense. Okay, so let's take a look at this just really quickly. I kind of want to know, why does a fraction exponent turn into a root? So for example, why is x to the 1/4 the same thing as the fourth root of x? Why? Take a second and think about why that makes sense. Okay, I'm assuming you've taken a few seconds to think about maybe why that makes sense. Maybe let's look at a specific example to see if we could illustrate that. So if we were trying to do something like 16 to the 1/4 versus doing the fourth root of 16. Over on the right, we would be trying to figure out what number to the fourth power equals 16, right? That's what we'd be trying to do, and it's of course 2. 2 to the fourth is 16, so the answer is 2. But let's look at how we might work that out over on the left-hand side. I think the easy way to work that out would be to turn 16 into a number with an exponent. So I'm going to turn 16 into 2 to the fourth. Again, 2 to the fourth and 16 are the same, so I've substituted the 16 out for 2 to the fourth, and I've still got my 1/4 exponent there. Now I've got a situation where I can rely on my basic exponent rules. Remember, when you have an exponent raised to an exponent, what do you do with the exponents? Hopefully what you said is multiply those exponents. When you multiply 4 times 1/4, you get 2 to the first, or just, 2. You get actually the same answer on both sides. And it kind of makes sense that you do that, right? Like, here's kind of another example too. Let's say we're talking cube roots. If we're talking, let's actually just write it in exponent form first. If we're talking about the cube root of 2 to the third, we know from looking at roots the other day that that's just 2 because they cancel out, right? They're the exact opposites. Cube root of 2 cubed is just 2. But guess what? If we were to rewrite this root as a 1/3 exponent instead, 2 to the third to the 1/3, those exponents really cancel out 2 and give us a 2 to the first, right? Or just 2 for when we multiply the exponents. A 1/3 exponent is dividing your exponent by 3. Remember the shortcut that we had, especially when we were talking about variables? We talked about if the index was 3, we'd divide all those exponents by 3 and see how many times it went in. It's really the exact same thing. Okay, so hopefully that at least makes a little sense as to why those are the same. They're really performing very much the same operation. Okay, now that we kind of have that, let's look at some specific examples here. Okay. Okay? In all of these cases, it doesn't really matter what format you write it in. So for example, doing 16 to the 3/4. One option is to basically do this, right? Figure out that the fourth root of 16 is 2. So if I'm doing order of operations here, the fourth root of 16 to the third, if you put that exponent on the outside, you can say, well, the fourth root of 16 is 2, because 2 to the fourth is 2, and then 2 to the third is 8. If you're more comfortable in root form, that might be the smart way to work out 16 to the 3/4 is turn it into a root first. But guys, you can work it out from this stage as well, okay? You can do this by turning 16 into an exponent, okay, into a number with an exponent. 2 to the 4th to the 3/4 is really the exact same thing as 16 to the 3/4. Now if I multiply those exponents, I get 3. And 2 to the third is 8. So another way to do it is just to write them out in exponent form, okay? And you can kind of look at the logic for all of these and how they are worked out if you want to see some more specific examples. But, you know, for the most part, guys, you can work this out however you'd like, okay? For example, here, this 8 to the 2/3 is the other example I want to go over. You have several different options. You can work it out straight from exponent form by turning the 8 into 2 to the third. If we multiply the exponents, we get 2, and 2 squared is 4. That's one option, okay? Another option is to turn it into root form, but remember, we have two different options there, and the order of operations would be different in both cases. Now, I'd say the way on the left is going to make for a slightly harder problem, because the order of operations there says square 8 first, and now you're trying to figure out what the cube root of 64 is. Well, if you could figure out that that's 4, because 4 cubed is 64, that's great. If you had written it like the way on the right, I'm going to underline that in red, actually, so I do that in a different color. There you would be doing the cube root of 8 first and getting 2. And then that squared just stays because we haven't done it yet. 2 squared is 4. Okay, so there's a couple different options always for how you can figure these out. But things that we should be able to do. Okay, things that is very, very, very important for you to be able to do. One is turn it in from either a root form to an exponent form, or from a exponent form into a root form. And then the other way is just simply figure out a way to evaluate these, okay? So let's take a quick look at some different possibilities here. Just a couple examples. You can write these off to the side. You can write these on a separate sheet of paper or something like that. Let's just do 2 examples of kind of each of those things there. So let's try converting forms, okay? So let's try converting from root form to exponent form. So here's a root. I want you to convert that into exponent form. Okay? Then I want you to, let's try converting the other way then. I'm going to give you something in exponent form. Let's go x to the 3/5, and I want you to convert that into root form. And then, so those are 2 examples of converting. And then let's try simplifying as much as we can with one starting in root form and one starting in exponent form, but you're welcome to work these out however you'd like. Let's go with the cube root of 8 to the 4th. And let's go with 16 to the 3/2. Let's go with 16 to the 3/2, okay? So take a minute, try all 4 of these. Again, the first 2 are you're just converting to the opposite format. There's nothing for you to evaluate there. And on the other side, I want you to evaluate and simplify as much as possible. Okay, so hopefully what we got here is x to the 7/3. Again, the key is that index is the same as the denominator of your exponents. That should be x to the 7/3. Here, going the other way around, 5 is going to become the index of my root, so it's the 5th root of x. Then that's all to the 3rd. You could write it this way, or you could definitely write it this way as well. Now, cube root of 8 to the 4th, you can do this in a couple different ways. If you just follow straight, the order of operations says, since the exponent's on the outside, I'll do the cube root of 8 first. So I get 2, and then 2 to the 4th is 16. Lots of ways we could have handled that one. For the 16 to the 3/2, I'm going to try to leave it in exponent form. And I'm going to, now I could just kind of do the square root of 16 to the 3rd in my head, because that's how I would convert that. But instead, I'm going to turn this into an exponent. And then I'm going to multiply the exponents. What this turns into is 2 to the 6th power, because 4 times 3/2 is 6. And then 2 to the 6th power is 64. Okay? You guys have a lot of practice to do with these, but it's pretty straightforward practice, and we're really just focusing on problems that mostly have nice, very pretty whole number answers. Okay? So you have 2 charts to fill out, okay? And what you have to understand about those charts, let me just look at the first one that you have to do. In this column, you're being given something in exponent form, okay? And then in this column, you need to turn it into the root form, okay? I'll actually do the first one for you because actually it might be the trickiest one on there. This would become, very literally, the 2nd root of 100 to the 1st. But guys, what you have to realize is, do I need that one exponent? Hopefully mentally you, or out loud even, you just said no, I don't need that one exponent. And we do not ever write a 2 as an index because it's understood that if I just write the root symbol, that it's a square root. So actually that's really the same as the square root of 100, and then the square root of 100 is simply 10. Okay, so that's what your final chart should look like. The second chart, I do want you to do both, might actually, instead of giving you a number in this column, might give you something in the root form first, and you need to make sure that you rewrite it in, when it says number, that means exponent form. So then rewrite it in exponent form over in the first column, and rewrite and write the actual numerical answer you get then over in the 3rd column. Okay? We'll take a look at what happens when these roots are not exactly perfect, or these exponent forms are not exactly perfect, and maybe some things we can do about it next class.